Hi, my name is Jesse at Trash Panda, and these are flight numbers. Basically, if you don't already know what they are, they're designed to tell you exactly how a disc is supposed to fly. But how exactly do manufacturers choose them? And why do some flight numbers seem to be completely wrong? Well, as a manufacturer myself, these are the very questions that I had to answer, and in today's video, I want to share 6 things I found that make disc golf flight numbers not quite as simple as they may seem. So Trash Panda started 3 years ago in my garage, and because I'm just generally interested in stuff and like to research the stories behind them, I researched early on the story of how flight ratings came to be. And buckle up if you don't know this one because it's a really interesting story. Basically, back in 2009, Innova started using this flight rating system. That's it. That's literally it. Basically, everyone is using 4 numbers because Innova started doing it in 2009, and that's the whole story. Which, for a sport that is technical, with technical standards, it was shocking to me to learn that the flight rating system wasn't standardized at all. So I wanted to first take you through the process of choosing flight numbers. If you're a manufacturer, there are 3 things that you can do. First, you can literally pick out of a hat. Now, I'm being kind of facetious in that no one's actually gonna do that, but because it's entirely subjective, you can literally just choose whatever numbers you think or want and just say, this is what it is. So, had we taken that approach with the Dune, our flight numbers would have been speed 14, glide 7, turn 10, oh god, and fade 4. So luckily, that's not the only way. The second option, and one that exists now but didn't exist in 2009, is to compare your disc to other discs on the market. And that could honestly look like anything from comparing the profiles of the discs themselves to comparing their actual flight paths. Okay, yes, there are a couple of problems here, but before we get there, the third thing that manufacturers do attempts to at least mitigate some of those risks. And that third thing is that manufacturers typically apply some kind of science to the way they choose their flight numbers. Now yes, I'm using that term very loosely because it's not super clear what everyone does, but as far as I can tell, the primary thing that most companies do is widen their sample size. Basically, all I mean there is that the disc gets sent to more people in more locations, so it's not just one person in one location, but rather a wider sample size. For example, the way that we do that is through our Patreon community. Which, by the way, if you haven't checked that out, I know I'm very biased, but it's awesome. You get access to things like our Discord server, monthly giveaways, and exclusive videos, let alone the fact that you can literally become a prototype tester or even just get access to things that we don't even release to the public. Okay, shameless plug over. Bottom line, manufacturers will typically use anything from 1 to 3 of those things to choose their flight numbers. And you're probably already thinking that those 3 things ultimately don't offer a full enough picture when it comes to the variables that can affect the flight of a disc. And you're completely right. I agree that there are just a few more variables that should be taken into account. And again, it's just a few, but those variables include the plastic, the flexibility, the weight, wear and tear, arm speed, form, wobble, spin, hyzer angle, nose angle, humidity, temperature, wind, elevation, etc. So it turns out there are actually way more than a couple of variables that can affect the flight of a disc. But I think we can take all of those and put them into 3 separate buckets: the disc, the person, and the context. And that starts with the disc. When it comes to different plastic types and flexibilities, as a manufacturer, how do I communicate how this disc is going to fly, how this mold is going to fly, if likely those things are gonna change. One option is that some manufacturers have chosen to put different flight numbers on their baseline and their premium plastics, which definitely helps, but there's still variability in there. With the inner core, that wasn't too difficult because it came in one type of plastic in one pretty specific weight range. But then we released the baseline, which was max weight, and then we also released the Dune. As of today, we've released the Dune in like 11 different colors with weights ranging anywhere from 167 to 177 grams. And on top of all of that, the material we used, because it's 100% recycled plastic, came from 3 different sources. Now, interestingly enough, whether you're using recycled plastic or virgin plastic, where you source your material will ultimately have an effect on the end product. That's honestly a whole rabbit hole we could get into, but basically early on, I decided to take all of the Dunes that we were gonna make with all of those variables and try to find one disc that fit in the middle of all of them. And that became the disc that I would use when trying to figure out how the disc flew for me. And if you're wondering what that disc was, you might even be able to guess because of all of the marketing materials leading up to the release, but it was the Dune in fire red at 171 grams. So that's great for the disc, but what about the person? I think we can all agree that there's one very obvious solution to this problem, age-old problem in disc golf, and everyone's just been waiting for it: disc throwing robot. And please don't get your hopes up, I don't have that one. But there is this new innovation in the space, it's super exciting, and rather than a robot, well, it's a computer. If you don't already know what tech disc is, then I don't know if you're just not a fan of overthrow or if you've been living under a rock, but this thing is seriously going to change the game, and I want to show you how it works. On the bottom of a disc, you have this little computer, and then it attaches to this app in your phone, and it literally tells you everything about how you threw the disc. Like, do you want to know exactly how much speed you throw with? It tells you. Want to know how much spin you have? It tells you that. Want to know how much wobble your release has? No, but it tells you that. Let me show you. All right, that felt pretty good. Loading up. Oh, loaded that quickly. All right, that throw was at 46.9 miles per hour. The hyzer angle was 4.7. The spin was 1150 RPM. Nose angle was 5 degrees. Launch angle was 10 degrees. And wobble is whatever. So this is where I think it gets fantastic. Basically what we did is we took this exact same setup and had it at the Dune launch party. During that time, we were able to record over 400 individual throws to collect all of that data to see how the majority throw. And then after that, I went out with the tech disc and threw it so many times. And while this isn't a perfect way to do it, we can at least plot my throw according to everyone else's. And if you want to increase that sample size, tech disc was recently set up at Worlds, and you can plot where I'm at according to everyone who threw it, including pros, AMs, beginners, etc. Now again, I don't want to sit here and act like this is absolutely perfect because it's not, but it at least shows you, say you throw at 40 miles per hour with 1,000 RPM, you can go, all right, if it's flying like that for Jesse, then maybe it'll fly like this for me. And I do want to say a huge thanks to Tech Disc for providing those and helping me comb through all the data. And if you want to know the exact data behind your throw, you can either get one directly from them, or a bunch of shops around the world have gotten them. So maybe call your local shop, see if they have it, and if they don't, tell them to get one. But I know there are probably already 17 different comments down below mentioning one important factor, and that's elevation. Okay, it's not really just elevation. It's wind, temperature, humidity, the entire context in which you're throwing. But yes, as people like to point out a lot, we're located in Denver, Colorado at 5,000 feet above sea level, and elevation change can definitely affect the flight of a disc. And ultimately, you can choose to just go throw the disc in multiple different environments and try that, but there is a way to get rid of all of those variables through a thing called computational fluid dynamics. Now, I'm not gonna get super in the weeds here because I went into depth on this in our video about choosing the flight numbers for the inner core, but basically Basically, computational fluid dynamics is like a virtual wind tunnel, and you're able to isolate those types of variables. And then you can run hundreds upon thousands of simulations to see how that exact disk would move through the air. And I should note here that our R&D guy Chris, between the inner core and the Dune, built a new computer just to be able to run CFD, and we have more data points than I would like to even think about. But what's crazy even after all of that is you still have to take computational fluid dynamics and compare it to real-world results. So basically, over the last 10 minutes, all we've talked about is a problem and a potential solution for that problem, which then brought up another problem, another potential solution, and the cycle continued. And honestly, because of that, my working title for this video was I hate flight numbers, because as a manufacturer, it just creates so many potential problems. But in the process of making this video, now after all of that, I think I might actually like them. Because in everything we've been talking about, there is one crucial element that I haven't mentioned. You. In today's world, accountability is at an all-time high. So now I think I see the whole flight number thing in an even more simple sense. Basically, as a manufacturer, it's my job to responsibly offer up some flight numbers. From there, it's you, the community's job, to hold me accountable. And then if after all of that I got something wrong, it's my job to admit that. And this isn't just hypothetical, because we've actually seen manufacturers change their flight numbers. So what may have started out as more of a controversial topic, I think is relatively simple. If I do my job and you do yours, then maybe, just maybe, together we can save flight numbers. Or the PDGA could just standardize them.